This example says an offshore well is located in the ocean at a point W, which is 6 miles from the closest shore point A on a straight shoreline. The oil is to be piped to a shore point B that is 8 miles from A by piping it on a straight line underwater from W to some shore point P between A and B, and then on to B via a pipe along the shoreline. If the cost of laying pipe is $100,000 per mile underwater and $75,000 per mile over land, how far from A should the point P be located to minimize the cost of laying the pipe? What will the cost be? So let's go ahead and draw a picture here of what is being described. Okay, so I'm out in the ocean right here, and I'm going to call that W to represent the well. And I'm going to give these other lengths some names. I'm going to call that C. I will call this X, and I'll call this Y. And then it tells us that from the well to the closest shore point, A, it tells us that this distance is 6 miles. And here's B. And then the point P is located somewhere between A and B. And we're trying to basically figure out where does P need to be so that we can minimize the cost. I also know that the distance between point A and point B is 8 miles. And so that means that the length from here to here, from point B to point P, has to be 8 minus X miles. So now we want to go ahead and define some variables. So I'm going to say let C equal the cost of this project. And I want to come up with an optimization equation now. And the cost of the project, it tells us that it costs $100,000 per mile underneath the water. And underneath the water is from here to here. That's the water part. So I'm going to multiply 100,000 times Z, because Z is the distance from the well to the point on the shore P. And then it costs $75,000 for all of the land portion of the pipe, which is everything between point P and point B. And we drew on our diagram that that was 8 minus X. And this is all equal to the cost. Now, we can't take the derivative of this yet because we have two different variables. We have X and we have Z. So our goal is to try to figure out how do we get this in terms of a single variable. Well, we know that the triangle that we have depicted here is a right triangle, and so we could use the Pythagorean theorem. So I'm going to go ahead and write my constraint out. My constraint is that Z squared is equal to X squared plus, and we know that the distance from A to W is a constant, and it's 6, so Z squared is equal to X squared plus 6 squared. And if I solve this for Z, I end up getting Z is equal to the square root of X squared plus 36. So now I can take that and plug that back into my optimization equation. So I get C is equal to 100,000 times the square root of X squared plus 36 plus 75,000 times 8 minus X. From here, I want to distribute in my 75,000. So I get the cost function is equal to 100,000 times the square root of x squared plus 36 plus 75,000 times 8 is 600,000 minus 75,000 x. Now, let's go ahead and take the derivative of our cost function. So I have c prime of x is equal to, I have my constant here, 100,000 times, I'm going to now use the power rule, 1/2 times x squared plus 36 to the negative 1/2 power. Then I need to multiply by the derivative of the inner function, which is 2x. And then the derivative of 600,000 is 0. And lastly, we have minus 75,000 here. So let's see, this 2 and this 2 will cancel out. And if we clean this up a bit, we get c prime of x is equal to 100,000 x over the square root of x squared plus 36 minus 75,000. I now want to take my first derivative, and I want to set it equal to 0 to find any critical values. And if I set it equal to 0 and then add 75,000 to both sides, I'd get this. And from here, I could divide both sides by 100,000. And 75,000 divided by 100,000 should give us 3/4. And then from here, we can square both sides. And we get x squared over x squared plus 36 is equal to 9 over 16. And then from here, what we can do is we can cross multiply. And we get 16x squared is equal to 9 times x squared plus 36. If I distribute the 9 in, 9 times 36 is 324. I can subtract 9x squared from both sides, and we get 7x squared is equal to 324. Then I can divide both sides by 7, and we get x squared is equal to 324 over 7. And if I took the square root of both sides, we get x equals plus or minus the square root of 324 over 7. And that is approximately 6.803. And we really only want the positive one there, because x is representing a distance. So finally, we can say point P should be placed 6.803 miles east of point A to minimize the cost. And the second part of the question asked, what would the cost be? What we could do is we could take our cost function and we can evaluate it for x equals 6.803, and we should get that that is equal to $996,682.70.